Number 20, prove each identity. So I've written the identity here for A. It's log A to the or Q to the power 3 of P cubed is equal to log base Q of P. So there is a shortcut where we can just cube here and keep it the same, but we need to actually prove this. So to prove this, we're going to have to show some steps. So to show steps here, what I want to do is I want to basically make these bases the same. So I'm going to use the change of base formula. So I'm going to just change this to base Q, and I get P cubed over log base Q of Q cubed. Well, the denominator is an identity. The denominator is equal to 3. I can bring this power here out to the front. So I end up with log base Q of P, and I'm going to bring the 3 out here, and then the denominator here, that's going to be equal to, that's going to be an identity. Let me keep this in blue. This is going to be an identity in the denominator equal to 3. Those are going to cancel out, and so I have left side equal the right side. The identity has been proven. In B, we have this here, and what we can do is we can try to combine logs. Now, the problem with combining logs here is we don't have, we don't have the same base. We have base Q, base P, and base 2. So one thing I can maybe do is just change it all to base 2. And I'm going to work on the left-hand side here, and I'm just going to change everything to base 2. So I have 1 over, there's my main divisor, log base 2 of 2, well, that's an identity. And I have log base 2 of P. And then minus 1 over, there's my main divisor again. I'm going to use my change of base formula, log base 2 of 2, that's an identity, log base 2 of Q. And that's going to equal the right-hand side. Well, this is equal to, these are equal to 1, and I'm going to put the denominator in the numerator. So that this denominator here, maybe I'll just highlight that in red, those are going to end up in the numerator. So it's going to look like this. So here's my fraction. So I'm going to end up with log base 2 of P, and in the denominator that just works out to be 1, and I end up with minus, put my denominator here. Okay, this is going to end up being log base 2 of Q, and in the denominator is going to be 1, and we can see how this is going to work out. We have basically subtraction of logs of base 2, so this works out to be log base 2 P over Q. When we subtract the log, it's going to go in the denominator, and this is now equal to the right-hand side. So identity has been proven.